first one we got from negative pi over 2 to pi over 6 of negative 2 cosine x times dx. So that negative 2 doesn't really do anything when it's in front of a trig function or an e or an ln. It just kind of drops down unless you got a chain rule situation, but we don't. So you can move that 2 outside if you want, or you can just drop it. I'm just going to drop it and say, okay, the integral of cosine is sine. So I have negative 2 sine of x from negative 90 to 30. So I'm going to put it in degrees right now. Just a little easier for me that way. So pi is 180. So 180 over 6 is 30. 180 over 2 is 90, and that's negative. So I have negative 2 times sine of 30 minus negative 2 times sine of negative 90. So sine of 30 is here. We want the y value, that's 1 tick mark up, so that's a half. So negative 2 times a half minus negative 2 times sine of negative 90. Well, negative 90 is down there. We want the y value, which would be negative 1. So negative 2 times a half is negative 1 minus positive 2. So number 1 would be negative 3. All right, number 2. So I've got the integral from 1 to 2 of 5 over x, which I'm right away going to rewrite that as 5x to the negative 1. And kind of the same deal as up there. I've got this constant as number 1. I've got the constant out in front. That doesn't really do anything. It just kind of falls down because the integral is going to be ln. So you could, if you want, like take this 5 and move it out here and put it back in later. But yeah, so the integral is going to be 5 times the ln of the absolute value of x. Now the absolute values won't really matter in this case because the numbers we're going to plug in are positive. But it's never going to be wrong to put it, so I just put it every time. So then I get 5 times ln of 2 minus 5 times ln of 1. And when you're subtracting, you combine the ln's with division. So 2 divided by 1 gives you 2. And that was a perfectly acceptable answer. So you can stop there. A couple people did take this and put it up top because there's that rule that says that you could do that also and then rewrite it as ln of 32. That's a little bit extra work than is needed. You're welcome to do it, but it's not required. Just going through it just in case you we're talking to someone that had that answer and you want to know how they got to it. All right, number 3. So the integral from negative 2 to negative 1 of it's 5 over x to the third, so I'm just going to rewrite it right off the start as 5x to the negative third. So now add 1 to the power, be negative 2, multiply by the reciprocal of the new power. So we got the 5 over 1 that was out there, times negative 1 over 2 is negative 5 halves, from negative 2 to negative 1. So negative 5 halves times negative 1 to the negative second, minus negative 5 halves times negative 2 to the negative second. Remember, a negative exponent just flips things over. So, if I have like x to the negative fourth, that's just 1 over x to the fourth. Or if I have 3 to the negative second, that'd be 1 over 9. It wouldn't make the answer negative. It just takes the 3 squared and flips it over. So negative 1 to the second is a positive 1. And then if you flip it over, it's still a positive 1. So this comes out as negative 5 halves. Negative 2 to the second is 4. When you flip it over, now it's 1/4. So in here, I have negative 5 halves times 1/4. So I have negative 5 halves minus, now this would be negative 5/8. So, and then the fractions are, for a lot of you, harder than the actual calculus. So it's negative 5 halves plus 5/8 when you do minus a negative. So if I multiply by 4 over 4 here, I'll get negative 20 over 8 plus 5 over 8, which is negative 15 over 8, and that was the answer. from 0 to 1 of 3 over 2x minus 6 squared. So first thing, bring that bottom part up. And then I've got a reverse chain rule situation here because I do have a chunk to a power. So this power is the big guy. This is your little guy. So if your L is 2x minus 6, your little prime should be 2. We don't have a 2 out in front. We have a 3 out in front. So I need to multiply this by 2/3 because then this is a 2 and then it goes away. And then I need to balance that out with a 3/2 on the outside. So to integrate, I add 1 to the power. And I multiply by the reciprocal of the new power, which would just be -1 again. So I've got this old 3/2 times the new -1. And then I'm evaluating that between 0 and 1. So -3/2 times 2 times 1 minus 6 to the negative first minus -3/2 times 2 times 0 minus 6 to the negative first. So 2 minus 6 is -4. -4 to the negative first would just take that -4, raise it to the first power, which is still -4, and flip it, which would be -1/4. So in here I've got -3/2 times -1/4. And the negative is not from the negative exponent, it's because 2 minus 6 was negative. So over here, I've got the -3/2, and then the same idea, this is 0 minus 6 is -6. -6, this just means flip it over. This times -1/6. And so I have over here 3/8, and I have over here 3/12. And then my common denominator would be 24, so this would be 9/24 minus 6/24, which would be 3/24 or 1/8. 3/24 is okay. Alright, 5 is the piecewise. So I want to integrate from -6 to 0 of f of x times dx, and f of x is 2 pieces. So f of x is x plus 3 when x is less than or equal to 3, and -x minus 3 when x is greater than 3. So the first thing I like to think about at least is I'm just going to make a number line. And I'm going to put all the x values that are in the problem on there and figure out what's what. So -6 to 0 is where I'm looking. But then obviously something happens at x equals 3. That's -3, sorry. So at -3. So it kind of splits it up into 2 sections. You got 2 equations. One equation is going to go in each section, and we're going to integrate from there. So this x plus 3 here, this applies when x is less than or equal to -3. So that x plus 3 is the relevant equation from -6 to -3. And then this -x minus 3 applies when x is greater than -3. So that's the relevant equation for this part. So we're going to integrate from -6 to -3, x plus 3. And we're going to integrate from -3 to 0 of -x minus 3. We're going to work both of those out and add them up at the end. So what we just did was take the piecewise function and split it into 2 separate integrals based on greater than, less than, and the overall endpoints. We're going to work both of these out. So 1/2 x squared plus 3x from -6 to -3. I'm just going to work out the first, the steps for each part as I go. So this will be -1/2 x squared minus 3x from -3 to 0. So over here, I'll have 1/2 times 3 squared plus 3 times 3. Oh, that's negative. Minus 1/2 times -6 squared plus 3 times -6. So this is not positive 9. Half of 9, I'm going to go 4.5. 3 times -3 is -9. Minus, so that's 36. Half of that is 18. 3 times -6 is -18. So all of this part over here comes out to negative 4.5. And I've got this part over here too, so negative 1/2 times 0 squared minus 3 times 0, so that'll just wipe out, which is nice. Minus negative 1/2 times negative 3 squared minus 3 times negative 3. So when this goes in, I'm going to get 0 minus, and I know what I get when I plug in negative 3 because I did it over here. I'm going to get that 4.5 minus 9 again, which is negative 4.5, and then negative 4.5 plus negative 4.5 is negative 9. Now, it won't work like that every time where the two answers are the exact same, so you can't just find one and double it. Sometimes it does, sometimes it doesn't, but I would not assume that. I would check both. Number 6, so they give me that f of x equals the integral from x to x squared of 1 over t minus 2 cubes times dt, and then they ask me to find f prime. So they're giving me an integral and asking me to find the derivative. That's a derivative. They're asking you to differentiate an integral. So in class, I recommended writing them like this. So the derivative of the integral. And then, remember the derivative and the integral part wipe out. And this dt is technically part of the integral part, so that's gone too. And what you've got left then is an x and an x squared on the outside. And then I'm going to plug in the top and multiply by the derivative of what I plugged in, minus plug in the bottom and multiply by the derivative of what I plugged in. On a lot of these, the bottom was a number, so the derivative of what you plugged in was 0, and that second part just wiped. But in this one it won't, because the derivative of what you plug in here is 1, so it won't just go away. So I'll get 1 over x squared minus 2 cubed times 2x, because that's the derivative of what I plugged in, minus 1 over x minus 2 cubed times 1, because that's the derivative of what I plugged in. And then I'm just going to throw those derivatives, or just the first derivative actually on the top. The second one doesn't have anything. But a couple people try to get common denominators there, which if you did that, that's fine. But I would also say in that one, you could just leave it. The common denominator part is not the part I'm worried about at this point in this type of problem. So you could just stop there on that one if you get that on tomorrow's or whatever. All right, number 7. So they gave me y equals x over 2, or 1/2 x, plus 4 from negative 4 to 4. Use 4 trapezoids. So the first issue is setting up your table. And I've got 8 units and 4 rectangles. So every rectangle needs to be 2 units in size. So this is going to be my first rectangle, second rectangle, third rectangle, fourth rectangle. I'm going to plug all those in to the original equation to get my y values. So negative 4 plugged in here would be negative 2 plus 4 is 2. Plug in negative 2 there, so negative 1 plus 4 is 3. And we're just going to get this 2, 3, 4, 5, 6 pattern. So the left-hand method, the base of your first rectangle is 1, and you use the height based on the left-hand endpoint, so 1 times 2, plus base is 1, left-hand endpoint is 3. Wait, these bases are not 1, I'm sorry, these bases are 2. So this base is 2, left-hand endpoint is 2. This base is 2, left-hand endpoint is 3. This base is 2, left-hand endpoint is 4. This base is 2, left-hand endpoint is 5. And if you remember, in a left hand, we'll never use the very right-hand number because it's never on the left side of anything. So this is 4 plus 6 plus 8 plus 10, so the left hand is 28. Then we got to find the right hand and average them together. The right hand is the same idea, except for each rectangle we use the right hand number. So we use the 3, the 4, the 5, and the 6, and we'll never use the 2. So base is 2, height is 3, plus base is 2, height is 4, plus base is 2, height is 5. And then 2 times 6, so 6 plus 8 plus 10 plus 12, so that is 36. And then the trap rule says you take the average, so 68 plus 36 plus 28 divided by 2, and that would be 32. Right? If I rewrite it, so there's this cosine of 4x, and then we had a sine of 4x to the fourth on the bottom. Just going to rewrite it as to the negative fourth. So I've got a reverse chain rule situation here. So this is my big guy. This is my little guy. So L equals sine of 4x. L prime would therefore equal cosine of 4x times 4. Which means I need this. So I've got cosine of 4x times 20. So I need this to be a 4. So I'm going to multiply it by 1/5. And this is the step most people missed, is fixing this 20 to turn it into a 4. So I'll multiply by 1/5 here. This turns into 4 cosine of 4x, which means it goes away, but that 1/5 needs to be balanced with that 5 out there. Then I integrate the big guy. So I add 1 to the power, making it -3, and multiply by the reciprocal. So that 5 times the reciprocal of -3, so times -1/3 is -5/3. And then don't forget plus c on your indefinite integrals. Number 9. I'm going to grab a new sheet here. So -40x to the third, cosine 5x to the fourth minus 3. There's another reverse chain rule. This is also indefinite because there's not numbers here, so don't forget your plus c. So cosine is my big, this is my little. So if my little is 5x to the fourth minus 3, little prime needs to be 20x to the third. And it's close, it's -40x to the third. So I would need to multiply what's in here by a -1/2, which would turn this into 20x to the third. And then that gets to go away. We'll put a -1/2 at the inside. I've got to have a -2 on the outside. The integral, I integrate the big guy now. The integral of cosine is sine. And I'm not plugging in any numbers, so that's where I put my plus c. Number 10. So let's do it on the actual test because it's all written out already. So what this is saying, like this shaded part up here is 2. This is -2 because it's below 2. And -2 because it's below. Yeah, okay. So from -1 to 3, so I'm going from here to here. Well, 2 and -2 cancel, the 2 and the -2 cancel, and this just comes out to 0. Part B, if we're integrating from 2 to 2, we're not going anywhere, we're not accumulating any area. So that one's 0. Part C, we're going backwards this time. I did flip those on you. So you would have to make your answer the negative of what it would typically be, but it didn't matter because these two canceled out anyway, so -0 is just 0. And then this one's saying, well, if I went all the way over to 5, now all of this has to add up to 8. So this missing part has to fill in that gap. So from -1 to 3, we've got a total of 0. Well, when I do 0 plus this, I've got to get 8. So that number must be 8. All right, hopefully that helped. Please come see me if you have questions.